Hey everyone, it's me Deepak. So here we'll be solving a very popular question that's named as search in rotated sorted array. So here this question or similar kind of question can be asked in interview because it's a very popular question. As you can see, the number of likes here is more as compared to the dislikes. So it's a good question and it is also a medium question. So medium the question. So yeah, the chances is high. So but don't be dependent on one question, just focus on learning. So here let's just go through the question. So here there's an integer given, integer array name is given, which named as nums, and it is sorted in ascending order with distinct values. So here ascending order means all the elements will be in the increasing order and there will be no duplicates. All the values will be distinct. As you can see in example, there is no duplicates. As you can see here in the example, it is given there is no duplicates. So here as you can see here sorted array is given. Yeah, so yeah, we might that binary search can be applied. So first approach that should come in a mind just by looking here that the array is sorted is binary search. So we'll be looking into that just, but let's firstly clear what question is saying to us, that prior to being passed to our function, nums is possibly rotated at an unknown pivot index k. Let's say pivot index is there, some reference index is there, from that index we'll be rotating our array, our sorted array into the rotated that will become so rotated sorted array. So yeah, and that k value obviously that should be less than num sort length and it should be greater than or equals to 1, and such that the resulting array, this is the position that where how that elements of position of the elements will look like after rotation. So here for example it is given that this array is sorted array, simple sorted array. So here if I have to find target in this, so I can apply linear search, but that will take over n time. So that's we'll just go with binary search, so that will take off log n time. So because we know that all the elements in the left side are the smaller as compared to the right side and it is sorted, we can directly apply binary search and we can find our target. So here let's say it might be rotated at pivot index 3. What is 3? So 0 1 2 3 add. So here from this and becomes after rotation it looks like this. We'll just go through it. Let's firstly just go through the question. So here what all things that we have. So here given the array nums after the possible rotation and an integer, I have to find what target, integer target, and I have to return index that where that target exists, or if it is not there, so just simply return -1. Yeah, that's the simple. And here we don't have to write O of n time and all the stuff. We have to write an algorithm with O of log n time. Yeah, so as you can see here rotated sorted array is there, target is 0. Yeah, it is present at what index? 0 1 2 3 4, at 4 index. Similar the array is same here, but the target is different, that is 3, which is not here. Target 3 is not here. No. So I'll just simply return -1, and here only one element is there, target is 0, which is not in the my nums array, so I'll just simply return -1. So here as an example, and here all the constraints is there that the element will always be greater than or equals to 10 minus 10 to 4 and less than equals to 10 to 4, and length will not exceed 5000. So all these are the constraints, all values are distinct. All just now we saw all this stuff. So here all that questions. So here if you have this company's option, just go to that, and the related topics as you can see here all the okay, let's go with this solution. So we have to find a target using binary search. I'm not sure whether I'll get that target or not. I'm just assuming that it is a sorted array, so I might get my target using binary search. So here let's say if you wanna code with explanation, detailed commented explanation, so you'll just go through this. Okay, I'll just add this link in the description. So here let's say to understand, so here okay, let's say this is an array, rotated sorted array. Okay, so what I have to do, so if it is sorted I can just directly apply binary search, but here if it is not sorted, so I have to find from what index, from which index. That index is called, as just now we saw, pick sorry pivot index. I have to firstly find pivot index. If I am getting pivot index, then it will be much more easier for me for finding that target whichever is provided to us. So here array is there. Cool. Now I have to find pivot. Okay. So here, as you can see, you can just go through this for the future reference. Okay, so here I have an array. This is the same array I just added here for, yeah. So here what happens, so here pivot, or you can say maximum element or the largest element in the array. So here which element is that? 7. Why maximum or largest element? Because as you can see, let's say before rotation, how it will look like without any some much calculation. How will it look like? Okay, it will look like this, kind of this: 0, 1, 2, 3, 4, and then 5, and then 6, and then 7. That's cool. Before rotation it will look like this. Okay, so here this is as it is, as you can see here, and 3, 4, 5, 6, 7, this is as it is. So what changes happen? So here, as you can see, this if you will just see this chunk and this chunk is just get interchanged. Yeah, it's just get interchanged. That's cool. So how it get interchanged? Because this is as it is, means let's just forget this. There's nothing like this. Yeah, so we have this stuff 0, 1, 2. I have added this. So means this first element, as you can see, from before 0, 7 is there, that is the largest. So here it this, see, this one, this came first here, and 7 came here, and after that what happened? Where is it? So yeah, so here after that 6 came here, 1 rotation, 2 rotation, now 3rd rotation 5 came here. As you can see, just see here what is happening here. So here 4 come here, yeah, and then lastly 3. That's cool. So here 3, 4, 5, 6, 7, 3, 4, 5, 6, 7, 0, 1, 2, 0, 1, 2. Forget about this. So here what I have to find? I have to find either this. I have to find either this maximum element or the smallest element. Yeah, because the pivot will be that only. So here there will be various approaches to find pivot. I will just go with finding the largest element in this rotated sorted array. The same case happens here again, that if it is sorted array, so we can just directly find my maximum. Yeah, we can directly find my maximum. If you are doing in Java, I can just directly do math.max. Means I can just simply find that. So here let's see that. I'll just go with this. Okay, so here what happens? So what the approach should I follow? Means firstly what I have to do here, I have to find pick element. Okay, pick element I have to find here. That's cool. So I come to know that 7 is my pick element. But how could I find? Means how I will say to in the coding language it, how is my pick element and all that stuff. So here, as you can see, if it is a normal sorted array, then if it is normal sorted array, okay, I'll just change the color. If it is normal sorted array, yeah, 0, 1, 2, 3, 4, 5, 6, and 7. So here, as you can see, let's say I'm applying binary search. So at 0th index, and yeah, at 0th index this element is there, 0, 1, 2, 3. Yeah, the element is same as index. 7 indexes, this is there. So 0 plus 7, 7 divided by 2, it is 3.5, which is 3 only. So here 0, 1, 2, 3 at 3rd index, whatever is there, this will be my mid. I can just simply see. So here it is my mid. So here 3 is my mid. So as you can see, mid, the specialty of mid is what? The all the elements in the shorted array, means see at the left of mid will be less compared to mid, and all the elements at right side will be greater than mid. It is the case with shorted array, but here it is not same. As you can see here, it is not same. Okay, as you can see here, let's suppose my 7 is mid, my peak element is mid, 7 is mid. As you can see here, all previous element is smaller, okay, but all right element, see here, right elements are not greater. If this is the case, see here, all the right elements are greater than my mid here in the shorted array, but in the rotated shorted array, all the elements at the right side are not are not greater than my mid. Here it is smaller. That's one case. That was what? Case number 1. And now what will be the case number 2? Okay, what will be the case number 2? So let's suppose my mid is this. Okay, my mid is this. Now all the elements at left has to be less than my mid, this, but it is not. All the elements are greater than mid. There is not even one element that is smaller than mid, and all the elements at right has to be greater than mid. That's this case is correct, but here all the elements are not smaller than mid. So here what will be the case? So here it is not smaller, it has to be smaller. This previous element, it has to be smaller, but here it is not smaller. So here it is not smaller, it is largest maximum element, and I have to find maximum element only. So I will just go with this. Yeah, this might be my maximum element. This might be my maximum element. I'm not confirmed yet. Okay, so here this, let's say, okay, this might be my maximum elements. This might be my maximum element. I'll again check. Just now we have checked like this way. All the elements at the previous at the left of 7 is smaller, but I have to find maximum element. Until yet now I don't know what is my maximum element. I'll just see at the right side all elements are smaller. So yeah, in this case I found that my maximum element is 7. Here my pivot is 7. As you can see here, I created a comment in notes. So here what I do, so your pivot is same as peak element or largest element. Peak element is what you should just check out that how to find peak element in mountain array question in Leetcode. If you didn't, so after solving that you will be much more confident for solving this question. So here pivot is index from where next element is starting, has in ascending order. As you can see, we know that pivot is my 7, and next element sorted, previous element sorted. So yeah, it is sorted. So what you can see here, what the difference you can see here when you compare with the sorted array. So here all where next element, see here, ascending order, and here also it is in ascending order. Cool. Means after rotation I'll get two parts, means here, and a partition will be from this pivot will be reference point will be that 7, that is the mid. All the elements at left and right will be sorted in ascending order. That's cool. Now as you can see in the above array, 3 4 5 6 and 0 1 2 is in ascending order. Only 7, okay, let's see, this is in ascending order, this is in ascending order, mid is this, whether this and this in ascending order. Yes, yeah, means till now everything is in ascending order, so we can just directly apply binary search without finding pivot. Yeah, means there is no need to find pivot now because everything is in ascending order. But what the problem is that here. So here this element, as you can see, is not in ascending order, it is in descending order, as you can see here. So I have to find pivot. There are various cases just now we have see here. We'll just go through that again, so just you'll be clear, much more clear with that. So here, okay, so here firstly what I have to do, I have to find pivot. Before doing, just don't jump directly into that. I have to find what pivot. So here pivot, you can say peak element, largest element, spell mistake, whatever element, maximum element, yeah, you can say anything. And please make sure that you check the problem that is found, how to find that, or finding a max peak element in the mountain array, that is also called as binomial array. So here I just created a method for finding pivot, so the code will be clear and it will be much more easier. So I'll not call my function, I'll not call the same code again and again. I'll just add that method name, so it will directly give me that pivot. So here I'm simply applying binary search here. Int start equals 0, same as binary search. Int end equals to that last index of my nums array, and now yeah, nums array is there. So while start is less than equals to end, same here I'm finding mid start for the simple purpose for this 0 plus 7 divided by 2 3 we are doing for our calculation, for human calculation. So we can do this also, but that is hectic, that is serious task. So here you can just, and also there is integer overflow, that might be happen. So here start plus end minus start divided by 2 will give the same answer. You can just check it out. So here this is the same until now we were doing in the binary search. So here I have to do what? For finding pivot we have cases here, some cases here, let's check it out. So just now I told you that nums of mid, I have to find mid. I got mid, I get my mid, okay, I get my mid. So as you can see my mid is 3, I get my mid. Let's compare this 3, okay. So here it is a sorted area, okay. So here my mid will be what? Okay, here my mid will be, here it is 0, okay, and here it is 7. Same at the third, at the 0 1 2 divide 7 divided by 2, it is 3.5, which is 3 only, floating value. So 0 1 2 3. So here mid is 6, my mid is 6, okay, that's cool, super cool. So here my mid is 6. I have to check this with my next element, means whatever element is after the mid. See here, as you can see here, okay, after 6, what is there? 7, yeah, it is greater than 6, and I want greater element, largest element, maximum element, peak element, pivot element, maximum, and that has to be maximum, greater among all the elements. Yes, I'm just simply finding my maximum element. So if my mid is greater than mid plus 1, here if mid is greater than mid plus 1, it is not, as we see earlier that if 7 is mid, I will check with whether 7 is mid, so mid plus 1 will be 0. Whether 7 is greater than mid plus 1, yeah, it is, means I found my pivot. But here, yeah, I'll just return that pivot, but here it is not that same case. Here my mid is 6, I'm checking with the mid plus 1, that is 7, whether 6 is greater than 7, no, it's not. So yeah, 6 is not my pivot. I have to check some for some other potential answer. So here what I will do, and also what will happen if my mid is last element? What will happen if my mid is last element? So here there's nothing to compare with, means if mid is 2, mid plus 1 will be what? Means it will be index out of bound error. So so considering that there should be we should write this, mid has to be less than end, okay, it should not cross that, it should be less than end. Yeah, this should be there, this and it should be there, it is not optional, it should be there, otherwise this case will happen. Cool, okay. So here it happened that the first case and the second case is what? just now we saw, yeah, whether means nums or, okay, I'll just show you here. Just now we saw that let's say my mid is this 2, this 0. So as you can see, if let's say for first if case only, whether my mid is greater than mid plus 1, no. So it is just a false condition. Yeah, I'll just come to that next question next, that whether my mid is less than mid minus 1, whether my mid is less than mid minus 1, which means this, yes, means I already told this to you earlier. Yeah, it is, yes, it is less than this. So here if my mid minus 1 is less than mid, and I have to find maximum element, greater element, which is not my mid, it will definitely maybe might be mid minus 1, but for now, for a particular answer, for now my mid is not greater here. For this scenario, my mid minus 1 is greater than my mid, so it is obvious that I'll just go with this. I'll just check it whether it is maximum among all the elements or not, but here in this scenario it is greater than 0. Yeah, that's cool. So here, okay, that's cool. So here I'll just return mid minus 1. Yeah, because this will only be the case, sorry, I just said something wrong. Here only will be the case when it is my mid is less than my mid minus 1. So here as in the general scenario, as you can see, my mid will never be less than my mid minus 1. See here, if my mid is 5, it will never be less than 4. If my mid is 7, it will never be less than 6. So here it happened, which means my pivot is 7. Just return mid minus 1. Okay, if not this case, I'll just go with another case. Okay, so here as you can see, as you can see, here is my peak element, pivot element 7, sorry, and all the elements at right, and see all the elements at left. See 0 1 2 is still same, as you can see here, like this is still same. What changes here is this. Okay, so 0 1 2 and the greater element than this means after whatever is there, I came here. So here the first element, this starting element, will always be greater than, or yeah, greater than this, not equals to, because there is no duplicate, greater than this last element of this, will always be, yeah, will always be greater than this, as you can see here. Because again I just took this part and added that here. I just simply do this. So all the elements, greater elements, is at left side now. Yeah, this point has to be clear for understanding this case. Okay, so I'll do what, I'll compare here. Okay, my start. Okay, so here my start element is what, 3. Cool. If my start element is greater than or equals to mid, why I'm keep on saying greater than or equals to greater than, because I want greater element. Okay, my pivot element. So here if my start is, see here, if this is greater than mid, yeah, let's say my mid is this 0, is it greater than 3? Yeah, it is greater than 3. If my mid is smaller than start, and here start is greater than mid, so I have to find greater elements. So this is obvious that if this is greater, all the elements here, just now I tell you that after all this element is greater, this element will be smaller. So there is no need to check here, I'll just directly check in this area na. There is no need to check here, because all the elements here will be smaller than start element only. Yeah, that will be the case. So here if my start element is greater than or equals to mid, So what I will do, I don't need, there's no need to check here na. So I'll just simply do n equals to mid minus 1, this, like this way, simple. If you want a detailed explanation, so here's I have written here commented detailed explanation. So here in rotated sorted binary search, all the elements at left of mid are greater than mid. Yeah, all the elements at left and mid will be greater than mid. Yeah, as you can see, this is my, yeah, that is the case. All the elements at left of mid are greater than mid. Okay. Okay. And all the elements at right of mid are smaller than mid. Here mid is smaller than start, and here we have to find largest. So I'll just do n equals to mid. Yeah, whatever I explained, that same thing. If it is not the case, if my start is not greater than my mid, let's say my mid is 6, my mid is 6, so here, and my start is 3 is not greater than 6. So yeah, there is no need to check here, because all the elements here are less than 6 only. There is no need to check here. I'll just do opposite of this, as we generally do in the binary search. If not this, then this case, as you can see, I commented here this case. Or after performing these 4 operations, if I'm not getting anything, just return -1. If I'm not getting anything, means here I'm returning -1. What does it mean? The array is not rotated. The array yet is not rotated. So just simply apply binary search. Okay. So here is just a simple method of binary search. While start is less than n, find mid. If target is less than mid, do end, something do with end. If target is greater than mid, do something with start. Else return mid. It's a simple, or else if I'm not finding my target, just return -1. It's a simple binary search. Here method of finding binary search. Here we use one method for finding binary search, and another method for finding pivot. So for finding binary search, in the binary, for finding target using binary search, you have to pass in which area I have to find my target, and what is my target, and what is my starting index, and what is my end index. We'll just see here why I'm taking these 2 extra values, int start and int end. Yeah, we'll just see here. So here are my main part. Yeah, cool. So here firstly I want a pivot. So here I'll just store, or I'll just call find pivot method, this one. It will give me a pivot value. So I'll just store that, and this here I'll just store that here in my pivot variable. Now I have my pivot. If we didn't find pivot, it means array is not rotated. Just now I said if it is returning -1, here as you can see, if it is returning -1, means array is not rotated. It is, so it is a benefit for us. It's just a base case. So I can just apply binary search simply. So here just apply simple binary search. Here just there's no need of pivot. There's no need. There is need after this only we find, but as you see here, there is no need to do, means we can just simply apply general binary search as we do generally normally for finding target. Yeah, here as you can see, binary search in nums array, my target is this. Now if here my array is not rotated, it's just a simple sorted array, so my starting index will be simply 0, and end index will be simply num.len -1. From starting to end, I'll just find my target, simple binary search. If pivot is not found, means it is not -1, it is something but not -1. So we have 2 ascending arrays, as you see here, 2 ascending arrays. Okay, 2 at left and right of pivot. See here, my pivot is 7. At left, ascending array. At right, ascending array. See here, ascending array. Okay, I already saw all this stuff. So we have 2 ascending array. Okay, so here my pivot, I'm not interested in index. My pivot index has what value, means what is that maximum, means till now we are finding maximum element. What is the value of that element? So that num so pivot will give me that. If my target is 7 itself, my target is my pivot, then there is no need to check here, there, and no pivot index. I will just return that if my target is pivot itself. I will just simply return index of that pivot element. I'll just return pivot. If not, or if it is not -1, if it is not same as target, then yeah, I have to search here or here. So for that there will be cases. So here after pivot, okay, that is elements at right of pivot are smaller than start element. Yeah, we saw all the stuff. Okay, so as you can see, okay, yeah, if my target, see we not here, so just now nums of 0 is what, this nums of 0 start. We were comparing now with my mid. If this is mid, this is mid, whatever element is mid, we were comparing with this starting element. If my mid is 0 and it is now here 3 is greater than 0, so yeah, then if my, just now we saw all the stuff here while we were finding pivot. Okay, now I'll find target. We saw now that this here, that if this element is there 3, okay, starting element is 3, so here if my target is less than 3, then we saw that all the elements less than my start is here at the right of pivot, at the right of pivot. Okay, so if it is less than my start, there's no need to find here. I'll find that here in this array, in this chunk of array. So there is no need to apply binary search in the whole array. So if my target is less than start, all the elements here you can see after that start is greater than start. If it is less than start, my target, then I'll just simply apply binary search here. If my target is greater than start, then it is obvious that my target is here greater than start. So it will never lie here. It will definitely be here only, somewhere here, but not here. So in that, so this is the cases we wrote here. If my target is greater than nums of 0, means if my target is greater than this start is 3, let's say my target is 6 or 7, whatever, means if my target is, let's say, 6, okay, now here it is greater than start, then check at left part of pivot, okay, because this 6 is greater than start, then all the elements greater than start is here only at the left part, at the left chunk of my this whole array, as you can see, at the left of my pivot, this part, because at the right all the elements are smaller than this start, or else I'll check at right part. So for this we use this here, start and end is different for different cases. Now I have to check only at left part, okay, here I have to check only at the left part, so there is no need to check. So now starting next will be 0, but now end will be pivot -1. Why pivot -1? Because I have already checked whether my pivot is target or not here. So till now my left chunk will be from 0 to pivot -1, that is from here, as you can see, from here to till here, or else at right part, that is from pivot +1 till the end of my array, that last index here till here. That's okay. So in this way, therefore we'll find my for target. So here we use 2 methods, simply just one method. Let's see our recap of all the stuff whatever we do. Peak element is the largest element, maximum element. Here in this case it is 7. Largest element in my rotated sorted array peak element is that. I have to find that. If I'm able to find that, then it will be much more simpler and easier for me for finding that particular target which they are asking. It will be much more easier. Okay, so I have to find pivot. So here method of finding pivot or maximum element, simply just apply binary search. I'll get my mid. If my mid, so here 4 cases are there, just go through this. I'll just add that link in the description here. So for the future there is commented detailed explanation also. I'll find mid, and there are 4 cases. I'll find mid. If so here if pivot is if it is returning -1, then array is not rotated, it's just a simple sorted array. I'll just simply apply binary search. If it is equals to target, if my pivot element just return pivot. If not, then these 2 cases will be there. Just compare it with the starting element. If you still not clear, just rewind, just go back and just watch the video again, so it will be much more clear if you didn't understand till now. Yeah, so just okay, so here you understand the concept also, and while explaining my concept, I also shown you the code. Yeah, this is all the commented part. Okay, so as you can see, I'll just show you here. I'll minimize it. Just come here. Okay, as you can see a code. Okay, that's all this thing I wrote for the understanding purpose for future reference. So here firstly I have to find pivot using method find pivot. I will pass here a nums array, whatever is given here, that. So here I'll just come, it will redirect me to this find pivot method. I'll find pivot using these 4 cases which we saw, and it will return some value -1 or something. If it is -1, it means our array is not rotated till yet. So just simply apply simple binary search. What does it mean by simple binary search? That so here start will be 0 and end will be that last index of that whatever the length of nums array is there. If it is if my pivot element is equals to target, so there is no need to apply binary search, no need to check at left chunk, right chunk, or whatever chunk is there. Just return that pivot index. If not, means if not -1, if not equals to target, then it will be in the left chunk or right chunk. If it is in the left chunk, this is the case which you saw. Just apply this start and end value, and if it is in the right chunk, just apply this start and end value. And for and this is a simple binary search. Just apply binary search in that. Because why I'm applying just simple binary search, because here it is an ascending order. We can just apply as a binary search. If it is in descending order, if I'm just assuming, then also you can apply binary. Means it is sorted ascending irrespective of ascending or descending. Okay, it is sorted, so I can just apply simple binary search. So here the second method which I use here at the last is method of binary search.